Chemistry, 1905. There's no mathy stuff in this, just a quick hit of vocabulary. There were 4 main topics that they covered, so if you were able to name those, you were good. So the 4 main categories are radioactive dating, medical imaging, radio labeling for genetic testing, and irradiation of produce were the 4 categories from 1905. They're just trying to explain to you, I think, in the midst of some things here that have been sort of scary about bombs and cancer-causing radiation and things, that radioactivity can be used to help mankind sometimes too. So that's what these sections were largely about. I'll explain this in a minute in conjunction with the traditional look ahead. So 1906 is the new read. There's 6 points worth of read. If you like history, you'll like this section. This is more of a historical section even, I think, than a science section in 1906. In terms of change arounds, okay, we're gonna ditch today's 5, 6, 7, 8. And we're going to start with the first scientist to create a transmutation through the cyclotrons and down for a while. We'll keep the rest of those questions. Those will all stay the same, no changes. The stuff from today's top 4 will go to the bottom, and it'll be an 8-point question instead of a 4. It'll go name, explain. So for the radioactive dating, you would do a little explanation that, and this is the longest of the explanations. For radioactive dating, you'd explain that the ratio of carbon-14 to carbon-12 is constant in living things and believed to be constant over time, but carbon-14 decays, and they can use that to date things. Don't have to talk about uranium is used to date non-living things, but it is. But basically anything living is made of 2 types of carbon, carbon-14 and carbon-12. So I'm not sure right now what that precise percentage is, but let's say right now I'm 80% carbon-12. If I'm 80% carbon-12, so are you, so is the bee that I killed a month ago, so is the grass that's growing, so is your cat at home. Anything that's alive has the same percentage of carbon-12 compared to carbon-14 right now. Then if something dies and later on you measure and it has 90% carbon-12 because carbon-14 decays, you could then try to play math games to decide how old something would be. There are some flaws in that plan, but I'm not going to belabor the point on the flaws in the plan right now. But that's the idea. Unfortunate thing for that whole idea, and I will squawk about this for a minute. For the math to work on that, you have to know what the percentage was in the environment when the thing died, which means you probably have to know when the thing died. And if you knew when the thing died, why would you be dating it? Okay, so there's like a little bit of a circular thing going here where they're like, okay, so we think this died then, we think the percentage of carbon was this, let's do math to date it. Hey, look, our date, it worked. It's when we thought it was. Well, no kidding. You did this whole circular reasoning thing here where you had to know what the percentage was when it died, so you had to know when it died for you to measure how old it is, and it came back the answer you expected. Well, no kidding. So that's my small rant on carbon dating. Medical imaging. Medical imaging idea is that you inject radioactive isotopes into something and then use x-rays to take pictures. Some of you and your families have probably had things like that where people have had to ingest some kind of radioactive thing and then they've tracked it to do medical imaging. I thought the book made a strange English choice that made me chuckle. On page 578, I feel like when they wrote the paragraph here on medical imaging, They shouldn't have said see figure 19.8 as their last thing. They should have worked see figure 19.8 toward the middle, because the way they phrased this, it says the small amounts of isotopes used in the procedures leave the patient's system in the normal excretory process, see figure 19.8. If you don't know what excretory process is, that's where food goes when your body is done with it and you take care of your basic biology, waste management business. That is called your excretory process. So when they say here that the isotopes will leave the body in the normal excretory process, it has you thinking about being on the toilet. And then while you're thinking about that, it says see figure 19.8, which leads you to think you might be looking at an unfortunate picture and you're not. So in my opinion, figure 19.8 has nothing to do with being on the toilet. It has to do more with the imaging itself of the person going into their bubble and getting x-rays. It made me laugh whenever it talked about the excretory process and told me to see the figure. It made me sort of cringe a little bit about what that picture might have in it if it had to do with the excretory process. Radio labeling for genetic testing is simply 2 words, tracking DNA. They talked about how they can track DNA with this radioactive scheme that they had developed. And then irradiation of produce is to inhibit bacteria or fungi or insect eggs or larvae. It keeps your food without spoiling for a long time or a longer time. So irradiation of produce just gets rid of bad stuff to help your produce last, or your food to last without spoiling. But that's what 19.5 was about. I'll see you for 19.6.